Before we get started, I'd like to go over some logistics. This webcast is being recorded, and to ensure a clear recording, everyone's phone line has been muted. If you have a question, go ahead and type it into the Q&A section of your GoToWebinar platform. This is located on the right side of your screen, and we will answer questions at the end. Our speaker today is David Fagerman, Transportation Technical Specialist for Autodesk. David has worked in the imaging, surveying, and photogrammetry arena since the mid-'70s. He has also spent the last 20-plus years working with multiple software applications to solve engineering and surveying problems. David, take it away.
Well, thank you, Noel, and welcome everyone to today's session. Today, what we're going to be covering is using Civil 3D to optimize design. And in that statement, we're going to use Imagery, which has been provided by iCubed and GOI, as well as DEMS provided by them, and then GIS information, and we'll run through civil data. So we're going to have a combined session here that runs from the beginning, from GIS and planning through the usage of satellite imagery. This is that high accuracy stuff that you saw probably in the last webcast, as well as some very nice surface modeling that came from the high altitude satellite data. And then we'll look at using civil with it and coming back and using the imagery again after we've done our design. So as we run through this, as I indicated, we're going to go through site determination with GIS, and then we'll look at the analysis using the satellite imagery and digital elevation model surfaces. Then we'll look at preliminary design, and this is where you'll get a good look at Civil 3D in action with our dynamic models and that, but using all the data that was provided above. And then we'll look at a quick visual prototype, taking our surface and our corridor and looking at it with the backdrop satellite imagery. So I think it's a very straightforward workflow. I think you'll get to see how this thing comes together. So as we step forward, we're going to start with a site determination. And GIS, and I've been preaching this for many years. I come from way back when before Civil and GIS were combined and they could work together with coordinate systems. We've talked about it, but you don't see it much. What you're going to see now is us taking accident patterns and costs via flood zones and land use, FEMA data, and then also probable growth and expansion, taking this information and then analytically using it, which is a classical mapping type thing. But we're going to use that, and we're going to show how that blends in with the imagery and the surface and the civil application. So I'm going to come over here now and run some little examples for you. So we'll start out with an accident analysis. So when I get in here, what you're going to be seeing on the screen here in a moment will be where we come in and analyze an accident condition. And so this is using pure GIS information. Now this is Map 3D, but it can be a workflow module of Civil 3D. So you could use either Map or Civil to do what I'm doing right here. So if you have Map 3D, this will take you through it. And all I'm doing right here is attaching some of the information, and we call this SDF as an example, or shape files, or Oracle data, any of the above. We're attaching this data, and this data right here will give us the opportunity to look at, for example, accidents that have happened in the past. So when you look at the right-hand tab over here, you can see we've had a correlation of accidents that have taken place in the past. And so as we do this, we can look at this data, and just like any GIS type analyst does, they'll get accident stuff. They'll look in here at the conditions of roadways and all that. And then what we're doing here, selecting this information, and we're going to turn around and basically what's called buffer the data. Because what we want to see, we want to do mathematics based on where an intersection is or whatever, wherever their accidents are. We can have a classical intersection where we've had 20 accidents in the last year or whatever summation time you want. And what we're doing right here is automatically creating an accident buffer around these areas. So that puts a perimeter around the accident spot. because when it's said and done, what we're looking at here is how do we best optimize our monies to save people's lives and to do the right thing on, for example, highway projects or whatever. We've got X amount of money. We want to come in and do something. So we're looking right here at different values. For example, E&F classification on land and on roadways. If they're classified in that low grade, that means they need to be worked on, but they also need to be looked at relative to accidents. So what we're doing here is taking the two, making buffers out of them. So we're looking at, we've got bad condition roadways. Give us a 100-foot buffer around these bad conditions. So when we apply right here, what will happen is we'll compute the bad areas. And these bad areas, I'm sure you can guess where we're headed. We're going to take this and we're going to combine this with the accidents, and we're going to find where the most probable and best place probably to spend money is. So we're going to come in here and do overlays, where we can say take a source of the land usage, take the accidents, find wherever they intersect, and these are going to be key spots. So what that does, because we're in a map type interface, is it comes in and it computes where they have similarity, as you see right there, and it creates areas so that we can buffer. So what you see here in a moment is a nice look at where the issues are. So from that right there, we first have come through here and isolated these problem areas. That's the first thing we want to do. Now we want to go through here. Another criteria is, and here again, we're using GIS just as part of civil. One of our criteria is we want to make sure that where we do this work, we're not going to lose it in 2 years, especially with all these floods that are going, like Nashville and the other areas where 500-year floods are hitting. So what we want to do is spend our money on the most probable area that's not going to get washed away in the next few years, because FEMA's going to reassess the flood zones. So what we're doing here is we combine a flood zone map with a land usage map. So we're going to take these two type things, we're going to look at it, and we're going to find out where these overlap. And so here we'll go right here. So we're going to take the land use, and what we're going to do this time is we're going to take the flood zone and we're going to erase the data that falls in there. So if we have a certain piece of land, industrial or commercial, the way we set this up, that has a 500 or 100-year flood, we're going to extract it from our model and not use it as we come in and determine where we want to do our work. So what you see right now then on the left is a model that's been looked at and that says, okay, this is in a flood area, we don't want to do it, but then we're going to come in here and we're going to say anything that's industrial or commercial that's in that has no flood area in it, use that as a query and find those areas. So that's what this will do right here, is it will find these areas. And again, this isn't classically something a civil engineer has been doing. But the point is, and the beauty of Civil 3D with this is that there's no reason we can't do this. We don't need to send this to just GIS groups. And I say the same with a GIS group. When you look at this, you're going to see civil work going on here combined with GIS. You can bring these together and you can find the best areas. So right here, what we just did is ran through that. We combined the land use in the flood zones, and then in a moment here where we're headed is we're going to come through here, combine the accident data and everything else, and come through and find out where is the best place to do our rehabilitation for the city or the state or the county. One other factor that you always consider is the traffic analysis zones done by the Census Bureau. So being that we just had a census done, you can come in here and take your parcels, geospatially located like this, look at them, and look where you've got an increase of population in the future or a decrease. So obviously where I'm headed here, I'm going to take all the considerations, and when it's said and done, I'm going to find a spot that I think needs to be worked on. And if I go to council or I go before the city and I say I think, if I don't have anything to back that up, that's nothing. So right here I can look, I've got future employees is greater than or equal to total employees or greater than 60 percent increase. So I can take that kind of criteria, find it, and then when I go in front of council or whatever and recommend this work to be done, I back it up by the fact that I've done legitimate queries. I've established the best cost and usage of our money and the most accidents. See what we're doing here, we're combining the accident areas, the proposed construction areas, all those buffers we just did, along with the land use. And what we're going to find out is where is the most probable places that we should spend our money to fix the roads. So this is the front end stuff, and those of you in city, state, and local, federal government, you know you have to justify your numbers, and that's what this lets you do. So what we just did right there is combined all this data, and that ellipse shows you, hey, we need to do something here, okay? So all this stuff is that preliminary planning. So we've looked at site determination with GIS. We just found the probable area. Now we're going to look at, now that we know where it is, we can get a hold of the iCube guys or the GOI folks, which they have all this great imagery and surface stuff, so we can get that, review existing conditions of site and surroundings, use their DEM data to look at existing conditions and make sure there's no gotchas that were not obviously picked up by the GIS. So we're going to come over here now and we're going to take, use their data, and now we're in Civil 3D. And what's going on right now, let me explain this. All that work was done in either Civil 3D in the map form or in map. And so what I've got right now is an empty drawing file. This is an empty drawing file, but I've got a coordinate system in it. So I want to work, for example, in state plane coordinates, but potentially all that other work was done in UTM or in some other system. But what I'm going to do now, I'm sitting in Civil 3D, I'm using what's called feature data object. And I'm going to come over here and grab the data I just used in the initial stop. So I'm going to call it my problem area. And I'm going to reach over here, grab that construction area, and pull it straight in this file right now. Okay? So I add it as a layer in my map. Remember that ellipse from the last session? Here's the ellipse. So what am I going to do with this ellipse? Well, first off, I know that's a probable problem area. Okay? One other thing I want to just do a quick look at is I would like to come over here and I'm going to set up a quick name view. This is just a little technique with Civil 3D, so or AutoCAD itself. I'm going to just set a name view for working construction because I'm going to bring in a bunch of data and I want to get right to it easy. So that's just a simple name view inside of Civil 3D. So now we're going to reach out and grab some more data. So what do I want to look at? Okay, so I can come over here and grab my parcel data. Potentially that would be of value to me right now as I look forward. So I want to look at where you think it is. I want to look at the parcel data, and then we're going to come forward and look at imagery and surface. So right in here you can see there's a jog and a roadway, and we all know that intersections theoretically should, you know, tie in right across from each other. And in all reality, when you have an intersection staggered like this, it's just asking for accidents. So what we're going to look at here then, we'll look at that accident buffer. Let's just make sure we fully understand that. So we'll pull it in, take a look at it, and we can see the other ones. In fact, quite often what you'll find is that it's either at a bad horizontal or vertical condition or at a bad intersection condition that you have a lot of accidents. That's a given. That's how come AASHTO has all the rules for the different site distance and things like that. But we can see it here. So we're going to use this one as an example. And initially, or earlier, we also did the check. It's not in a floodplain. It's in an industrial commercial area, as well as it's got a growing population. Now what I'm going to do right here, this is Civil 3D. We've got all this design that could be out there right now that we could get from any data source, a geopacker or En-ROADS, save the land XML. We simply put it in Civil 3D, put it in what I've got here is a shortcut directory where we can just promote these into this empty drawing. So these alignments could have come from any source, from any Civil app, and of course as well as Civil 3D. So we're looking at this, we can get a good feel. Well, here's the geometry. You know, that just doesn't look good, obviously. So, you know, that query makes sense that the GIS did. And the GIS now could be a civil person, not just a geo person. Now, here's where we're going to go in and grab the satellite data. So, where this nice high-res imagery has been provided, we're going to just come in and grab this. This is a huge file, but by attaching this via feature data object, which is what I'm doing right now, it carries an extremely light footprint into the drawing. So it's not like insert image. It's attached image. It's like a reference to the file. So here I'm carrying this lightweight image, and I've got all this data coming in so I can look at it. So I'm going to bring this data in, and as we get the data, we'll backdrop this imagery on it, and we'll take a look at this here in a moment. So we're bringing the imagery in. In a moment, you'll see it there. And this imagery, again, like I said, is that really nice high-res stuff. And as this stuff goes on, what I want to do is use that name view that I did and come right down in the image and look at that area. And so very nicely here, we use stuff provided by an on-site or by a service provider to get this data. And the guys have all this for most states in the country, as their webcast a couple weeks ago. So very, very nice imagery. We can look on this in a moment, and we can see, you know, what's going on here. So we have a legitimate feel for the data. So here our imagery comes in, and in the moment, though, I say, okay, well, that makes sense. So I'm doing my analysis. I'm thinking as I go. But one other thing I'm not sure about, what about the surface here? And again, see, it should have been picked up in a GIS probably. If there was a low point or whatever, the FEMA stuff would have picked it up. But here now, we're going to grab the surface, look at it, and this is where we can use the Civil 3D import. Again, this came from the folks at iCubed and GOI, where we're going to reach in, grab this data now, and what they did is they provided me a couple days ago with the data that was projected to the coordinate system. And when I bring this data in, I need to make it clear, even if they didn't put it in the system, with Civil 3D, you can do an on-the-fly transform from that data simply by having a header in your file that says, this is UTM data, bring it into NAT 83 state plane. So I'll have this data here in a moment, and this is a very large surface. I believe it was about 1.4 million points. You'll see it here in a moment. And so what we're going to do is look at this surface relative to where our geometry is. And we'll just visualize a couple different contour settings on it, and we'll look at it. And so what I've got as this thing comes up, I've got an image so I can look at it for sanity check. I've got a surface so I can do a sanity check on my surface. And I've already established this is the right place to work. So now I'm going to move ahead and do actual work. And what we're looking at right here is where you can look inside the surface model and compare, you know, does it look right elevation range, things like that. So that gets me ready. I'm ready to go. And then one last thing, this is just a Civil 3D thing. This will come up in a moment. We're broadcasting a lot of data here. Is when you build a surface like this or you do things like this, you can do what's called a shortcut and check it in. So when you go to the next stage of design, you go in an empty drawing and just attach this 1.4 million surface as a shortcut. So you don't have to carry the big thing with you. It's a very nice way to go. So that gives you a little look on how we get that data there. And just a moment here, I'll get this out of the way. A second. There we go. Okay. All right. Now the next thing is we've established there's no gotchas on this. So then we want to look at engineering preliminary design. So here I'm going to rush through these a little bit just for the sake of time, but I want to show you the general process. We've established that we need to do stuff here. We've already grabbed preliminary data. In fact, based on that surface model, it may be adequate enough to let us do a real good preliminary look at this and do the design and see what kind of takes we're doing in that. The touchdowns will be close. So then we're going to create a 3D model out of it and review, does this make sense to do it? So I'm going to go through these sessions a little bit quick. We'll run through Civil 3D. Now you're going to get a look at outright Civil 3D. In fact, all of this has been Civil 3D, but in this stage right here, what we're going to look at is the geometric layout. In fact, I'm going to move into it a little bit. We've got our data right here. As this comes in, we've established it's the right data. It's what we want to work on. And in fact, right here, we can use that data shortcut stuff to bring the data in. This is nice. So you can be in an empty drawing file and just bring the data in, just like that, just what you want. So you're carrying a very lightweight DWG. You bring it in, you can see it, and then all this data you have access to. You can view it, do whatever you want, or you can bring it right into this file live and make edits to it if you like. So we're going to use this data, run through here now, and I'm going to move ahead a little bit. But one of the criteria is, and we all know this with road design, is number one, we'd like to have a single point of intersection, okay, of the two roadways. So we're going to establish that. Number two is that we're going to want to have a particular minimum angle of deflection at the intersection, such as an 80-degree angle. So one of the things you have to do in civil engineering, obviously, is come in here and put in pure coordinate geometry. So what we're doing right here, we're going to take the tail ends of these roads and make a separate alignment out of it, okay? So I'm going to grab the bottom and the top, or in other words, the southerly part and the northerly part, make geometry that I can use out of it, and then I'm going to turn around and use straight up geometrics to compute how the geometry should fit together. So in other words, I've got two tangents. I'm going to compute a point on the roadway that will be a predetermined point at a particular station along the main line. And what we're going to end up doing then is turning an angle off that, and I'm going to speed it up a little bit for you here because we're going to cover a lot of stuff. We've got the tools in here where we can come in and do free, fixed, float geometry between the tangents. So we can do all kinds of best fit in here to make things work. And this way we can find the best geometry. And as part of any of your engineering, you have to be able to put in engineered curves in that. And again, that's what Civil 3D excels at. It's got PEI-based, element-based, best fit-based, COGO-based, every type of alignment geometry you can think of to do your work. So if you need to come in and set a point on the roadway, it's very easy to set it and then turn a deflection angle and then fit the geometry. So you have to be able to do this to go to the next stage in anything. So I'm going to move ahead here, and what you'll see is where I can also specify a criteria. So for a municipality, a state, a federal government, a county, you can have your own criteria as part of what you do with Civil 3D. So we can take this criteria that has certain radii, certain gradients. For example, in Tennessee, if you have a certain gradient on a highway, you have to change the speed for trucks. So we can have design checks, and what you'll see here are these little triangles that say, hey, you got some kind of design issue here. And in Civil 3D, it knows what it is. So it'll come in and say, well, you know, your transition lengths aren't good, or whatever. It will tell you exactly what the issue is. And what the key is you can set up the criteria based on your own locale. So again, design criteria. So when we do design, we're not just throwing data out here, we're using legitimate design, okay? That kind of gives you a little idea how that one works. So I'm going to move on. So let's say we computed that geometry. Now we want to go to the next stage. And the next stage, in just a minute, I've just got a little Camtasia thing where I have to grab the, not Camtasia, grabbing my view. There we go. Okay, now the next thing, what about scenarios? Let's look at a scenario, okay? What ifs? What if we put this connection in just like this? And what if, and as you know in Europe, they think highly of roundabouts. In the U.S., you're starting to see them pop up. What if we put a roundabout in here? And I'm going to just whip through this quick. Civil 3D lets you take this data and come in here and compute a what-if scenario, which is what we want to do. So we've got these in here, and what we're going to do now is come in and see if a classical roundabout would work. And so we'll come in and set our standard CAD settings, and we're going to grab each of the corridors or each of the geometries that come in. And then as it does this, and I want to make sure it catches up, I'm watching a monitor, you'll see a little dialog that pops up for roundabouts. This is built in Civil 3D. So if in your community you want to see, well, will a roundabout work? Well, do one of those roundabouts by hand. All that geometry, all the tapers, it's a serious deal. So here you can use your own local standards for roundabouts or delivered standards. So when you look at the roundabout, you can see, does that make sense for the deflection angles at this intersection? If it doesn't, let's do something else. So I'm going to speed this up a moment just so you can see as this thing comes through, and it will compute it here in a moment. And it takes seconds to do these. That's the beautiful thing. And what we'll do is take a quick look at this, and we'll see that we have overlap problems. Now, there's two things we could do. One, we could adjust the geometry and go forward again. Or two, we could say, hey, with this intersection geometry, especially because of like this back curve, you notice as we swing things, the geometry changes. So we could look at what ifs with our alignment geometry, but we still see we got a problem if we want to hold minimum radii. So this gave us an immediate feedback and let us make a decision. No, we don't want to do a roundabout. We're going to go to the next thing. Okay, so we're going to go to the next option now. And what I'm going to do is drop this one off. So I use roundabout as an example. And seriously, you can take an intersection, know what your radii that you want to put on it, and I mean literally in 1 to 2 minutes you can analyze the geometry if it'll work. That fast. It's extremely fast. Now what we're going to look at now is the next level, and this is the more probable level that you run into. This is where you come in and you're going to take this intersection and we're going to look at an on-grade intersection, okay? So this is an example of an on-grade intersection with widening. So we've got the two alignments coming, and we looked at it and we said, you know, that roundabout just doesn't work. And I'm going to move through this a little bit quick, but what I'm going to do first is create what's called offset alignments. Because what I want to do is I run through this, on a curve on the inside, I want to increase the width automatically. So based on that, I can say increase by 3.5 and put a transition length from, for example, a 12-foot offset to a 15.5-foot offset on the inside of the geometry. So I'm setting up the conditions I want to deal with, and you'll notice here what happens is it computes the data. So it knows it's offset geometry that I'm going to turn around and I'm going to use. And I'm sorry if the screen hadn't caught up with you. It should be there now. You should see offset geometry. This geometry then I can use and connect in my corridor intersection. So you need things like bay tapers, oscillating widening from in a curve where you go from one radius to another, or straight line interceptions. All of that we have available via our widening options. So you create your widenings, and then you turn around and we have automated intersections that will let you take that data. And what you're seeing here is quickly just automated intersection that will come in and they'll say, well, what are the side alignments that are going to control this? And so those, for example, could be our widenings. And in a main corridor, there may not be any side alignments. It may be just following the typical section. So you'll see here a little bit of selection of these tapers. And that's, you know, again, if you're going to do corridor and things like that, you have to be able to select things like that. So these, again, they could be bay tapers. They could be a oscillating circular transition. They could be a straight line transition. You select them and put them in here. And what you see right here is a collaboration of a main road and a side road, and then the quadrants, the 4 quadrants, for example. You can come in, set up the radii or how you want things to behave, how you want things to transition. And if you look on the little bottom here, you'll see a little thing that shows you each entity as you touch it. What the value does, how it manipulates it. So what you do is you set these quadrants up, and then when you do an intersection, and you do any modifications, everything updates with it. So this includes both the typical section as well as all the horizontal and vertical geometry. And so the vertical geometry is coming from the two intersecting alignments, incoming and outgoing. Instead of you having to calculate it, it's all done automatically. So all the geometrics are done horizontally as well as vertically. And then you associate like returns and widening segments. And then what it does is it'll come through and automatically compute that. And this is something that Autodesk has actually a patent on, whereas it will automatically do this calculation. And you can have all this set up ahead of time in your own files. Now what's real nice about this, it does all this math, and that's good and nice, which anybody that's done a lot of intersections, you know how long it takes to get all that together and how error prone it is. And what we'll see here in a moment, you'll see the intersection that's created from it. You see that right there? So you can see the widenings and everything. But the beauty of this thing is, if you modify one entity, everything else updates. The other beautiful thing is all your pavement substructures are put together. See, we're not coming in here clipping stuff, trying to connect and make the models, all that stuff. It's all together. And you all know how links work. Well, you may not, I'm sorry. But we can have links on the data, which are the different substrata automatically. So we can have not only pavement structures and things like that, but as well as surfaces that we can drop straight out to machine control and then do the machine grading on. So this thing gives you unbelievable power. And then right here, the other really nice thing is you have dynamic edit capability. So all I'm doing here is calling up a quadrant, and it will come in and edit all the geometry with a quadrant and update. What we're doing right here is updating what's called the region. And this will take that corridor, take any radius changes or anything, update it, and then all the models updated. That's the beauty of Civil 3D dynamic modeling here, in that anything you do like that, it automatically happens. So that gives you a quick look at creating it. And all this stuff, as you recall, came from that GIS data, right? Let me get this down here and kill it. Okay, and I'm going to step through again for a moment here on the next piece that you have to do. And like I said, we're showing Civil 3D in this too. We're taking it through it, but I'm going to run a little quicker here. What we want to do here then is look at, we've got the corridor, but as we come through here, we need to develop what's called super elevation. And so as I bring this forward, I can look at the super elevation calculation. And so what I want to do, you know, as part of any real design, you have to look at the whole thing, not just the typicals, but the super. We give you a very nice little workflow wizard type things like this that will step you right through the super calculation, so you don't have to know all this stuff and fight it with a tabular mode or whatever. It will come in and compute it, let you use whatever standards you want to use to compute it. Then you can turn back around and do all types of editing and usage of it. And so the way this works, all this stuff is going to be computed here in a moment, and we're going to turn around and apply it to the horizontal geometry. So when we run our typical sections through this, we'll take the super, apply it to the typicals, and we'll have a truly built roadway. And I'm going to step ahead just a little bit here to a tabular look. And what you'll see here in a moment, this is a simple tabular look at the data. If you want to work in tabular, you can even bring it through like Common Delimiter or Excel sheets, or let the software compute it like I just did. And then you can come in and look at super diagrams. Now, instead of just operating in a tabular mode, we may want to operate in a super mode, super diagram mode. This lets us look at roadways in a longitudinal fashion. And in fact, this is beautiful for like that satellite imagery combined with the surfaces and that to extract existing longitudinal super diagram data into our diagram that I'm going to do right now. I'm not doing that in this section, but that's one of the things we quite often show people as we do it. So what you'll see in a moment here is we'll take this data and we're going to build what's called a super diagram. And in a moment you'll see it here. This is a band diagram, but with a super elevation left and right in it. And this super information then has what's called grips in it. And this is where we're tied straight to AutoCAD. Now we can come in here, tag this thing, and grab a grip and do edits to our super. These edits to our super, and the moment you'll see it here, will reflect back in our tabular data, as well as they'll go straight to our road and affect the way the roadway translate or interpret super. So what I'm going to do here, I'm going to move up just a moment. You see the grips in a moment. You'll see them here. And it gives us options to change cross slopes, to change station, to delete stations. So if you want to come through here and change your super on the diagram, you can. If you want to take out transitions on the diagram, you can. If you've got very near compound or not compound, but curves all to the same hand that go in the same, but with a small tangent, you may want to take the tangents out and leave the super through there. So you can transition in a tabular mode as well as in a super diagram mode. And as I step forward here, I'm going to move ahead. You'll see a little super diagram that's been modified, taking out the normal crown. So that's what you see there. And then as you go a little bit further, this data will come forward and it will update the super tabular data. So again, we can even do the tabular data. So these are the things that you have to have to do your design, and they're built right in automatically. So now what I want to look at just for a moment, and I'm going to run it quick. We've got our horizontal, our vertical built. We've got our super put together out here. We want to look at a little bit of corridor modeling. And what this is right here, these are our typical sections, which we call assemblies and sub-assemblies. So for example, this one right here is for overlay. It lets you come in and do an overlay, and I'm going to wait a minute, make sure you can see it. Okay, you see these typical sections here? These come from a catalog that we provide. And we have several examples. They're like Tinker Toys. You grab them and put them together, but they're also what's called parametric. So as you put them together, they interact, but they also enable you to set different values, like for width and slope and depth and reaction. Do I put a guardrail in based on a height, things like that. These are the concept that we use to do our corridor modeling. In a moment here, you'll see where we can come in and look at what's called an assembly in its whole. And when that diagram comes up or tab, you can see over here on the right, upper right there, what that is where you can key in different values. It's parametric. It lets you do rounding. It lets you do smoothing, all types of stuff. So you can take these typical sections in, and what you do is you can combine them with our corridor process. So we take the typical, we put the horizontal with it, the vertical with it. We have it target a surface, which would be from that GOI and I-cubed, and that's what we're using to target right here. And then when we come in here, we can grab this, and almost everything in Civil 3D is where you can touch it. And notice how that top ribbon changes up on the top. What's happening there is we recognize the noun being the corridor, and the verb action is the command that's provided to you. So it's a noun-verb action. And so here, when we want to do a corridor, we simply touch the corridor, and it's going to make the commands available to us that are appropriate to a corridor. And I'm telling you, once you start using this kind of technology, it's terribly hard to go back to the verb noun. Like a microstation, if I want to delete an entity, I hit delete and then the entity. If I want to do it in Civil 3D or AutoCAD, I touch the entity, which is the noun, and then it gives you the option to delete. So it's things like that. That noun verb, you get used to it, and it's hard to go back. So so what you see right here, just as quick as that, we grabbed the geometry and we created that northeasterly piece of roadway. We're going to do the same kind of thing now, simply with the northerly piece. And I'm going to move up on this a little bit quicker. So we grab it, and the one difference here with this is that we're going to need to select left and right widening. We just simply, with a data button, connect to this, drag the roadways, and what this lets you do, instead of getting in that tab and having to key it in, you can either key it in at the command line or drag the thing where you want it and do what ifs. So here I'm doing a side road, what if, and I'm going to specify an assembly. That's that typical section that would match that side road's geometry. See, very simple to do that. And then all I'm doing right here is say target the GUI surface. And then, but the other thing is, here's an example where you can target control lines, like those widenings that we did earlier. So I can come in here and I can select control lines for the left and right sides of the road. And then when we do our corridor, it will tie to those things and it will stretch accordingly. Now, in the sake of time, I'm going to move it ahead a little bit. And you can see right here, in a moment, you'll see where it generated that corridor very quick, very easy. Okay? And one other thing that that's very neat, in a moment here, we've just added some functionality to copy pieces. So you can just come in, grab that northern segment of roadway, drop it on the bottom segment, have it remember all the typical sections, any targets that were used, any interval that's used, drag the thing down here, and what it will do is it automatically will build the bottom of the road. So design gets just crazy fast here in what-if scenarios. So it's not like jumping back and forth to tabs. It's all done in a graphic environment with a ribbon that triggers based on what's going on. And like I said, you get used to it. It's hard to work otherwise. All right, just a second here. I've got to get where I can grab this again. Have a moment. There we go. Okay, so that does that. I'm not going to get, well, I do have a moment. I will run this corridor edit. I'm going to show this. This is really neat. You've done the design, and then you want to come back in, and you need to make some edits to it. And again, I'm going to wait for you guys to catch up with me screen-wise. Should be here shortly. There we go. So, in fact, I may have grabbed the wrong one by accident. I think I did. Excuse me. Let me get that back. Have it right back. There we go. Now, this is where you want to make some edits quick. We've already done this corridor. This is the beauty of that dynamic model that we talk about. We've got the corridor built, and I'm going to give you an example. What you're going to see here is one of the things as we get in here, like in curves, if you get into machine control and you want to dump out all these sublayers to machine control, one of the techniques is that you want to densify the machine control section. So as quick as that, we can take the graphics. So you see this graphic here, you'll see it in a moment, highlighted, and we can come in and with just automated tools do what's called a split. So we make it what's called a region, separate regions. And the reason we do it is we want to go to machine control, and what we want to do is take one region and densify it. So you see it here in a moment pop up with the densification options. And so we can densify this so we send more data out, and including super data, for example. The full super points, all surrounding the transition points, the profile highs and lows, we can pick up these additional points in our corridor so that when we go to machine control, we send all that out. And you'll see it here in a moment, a densified model that does not miss one piece of data that's needed to ensure we match the exact design. So that will let you come through. Now, one other thing, we've just decided we need to finish this roadway up here. We just got the word from the contractor how they want to proceed, and the engineer. And again, you're going to have these nice grips, again, that are noun verb based. So we touch this, you see the tabs, and it's saying, hey, you got access to do different things. What do you want to do? They're highlighted up on the ribbon up top. So we can take that and we can say, well, we want to copy the section to the northeast of the intersection, copy it, and we want to fill the gap with it. So we're going to take it and run it and fill the gap. As easy as that. You don't see us jump in tabs, key in stations, all that, which is very painful and time-consuming and error-prone. And then also, speaking of error-prone, this will pop up and warn us that, hey, the target's not found. And the reason the targets aren't found, excuse me, is we took that geometry from the intersection, which had widening targets. Okay, so we don't have any widening targets. But again, the beauty of it here is that noun verb. We touch that piece of region, the region of the corridor, it pops us right into the dialogue as it should, and it lets us come in here and turn those widenings off, which I'll show here in a moment. We simply come here and we delete the left and right widenings. As simple as that. So notice right here, this is where we're controlling horizontal and vertical geometry, okay? So this is the vertical right here being deleted, and a moment ago we took the horizontal off. So when we do that, as soon as we say OK on this, it regenerates the model and the errors go away. So as quick as that, we can bring one of these back into condition. That's the dynamic model. So we've created this nice looking model now, okay? So what are we going to do? We'd like a quick visual prototype of this guy. I want to look at it on the imagery. And then I also want to look at my GIS parcel takes, you know, because I just now figured out where my slope intercepts are. If I'm going into somebody's place that I know is going to fight me 2 years in court, I may change my mind on this. So all the decisions you have to make are available to you. So I'm going to pop this one up, and I'm going to give it a moment because it's quick. I'll make sure you can see it. I'm going to just check the viewing here, make sure you can. Okay. So what you see right now is the imagery, and what we're going to look at is taking this thing through using our map interface. We're in Civil 3D. We've got the full engineering data in here, and we've got the imagery in here. We've got the surface in here. We've got the corridor in here. And what we want to do now, let's look at the parcels. All right? So we've got the parcels. We've got the imagery. We've got the surface. We've got the corridor. So now we can make a legitimate look at this, and does this make sense? So this is where you combine all the data and you come up with the right answer. And that makes it very easy on you. And I thank you for your time on this, and I'd like to move it to open Q&A at this stage. And Noel, I'll hand it back to you if that's okay.
Yeah, that sounds perfect. David, thank you very much. That was a fantastic demonstration. We had a number of great questions come through. For everyone on the line, if you have any further questions, if you have a question that doesn't get answered, go ahead and type it into the Q&A section. David, let's go ahead and start off with, can you tell me more specifically some of the GIS data sources that can be used in Map 3D or Civil 3D?
Yes, some of the examples we used, for example, was SDF, which is a native format from AutoCAD or Autodesk. It lets you save out objects like pipe networks and alignments, things like that. It can be other things like ESRI data, shape data, and that shape data can be 3D based or 2D based with unlimited attribution. It can be ODBC databases, it can be Oracle, it can be multiple data sources. Pretty much there's a feature data object connector available for many types, and it's an open forum where if you want to add your own particular type, we've got that access to the API for you. So that pretty much that's it on that one.
Okay, perfect. Let's say we have another one. If you have right-of-way information available only as an image, what is the best way to use this information in order to develop a corridor model that does not encroach on the existing right-of-way?
This is an extremely common situation. If the data is to scale, and it's on hard copy, if it's to scale, you can take that data, scan the data, and then you can come in and put, for example, if you know state plane points or anything like that, or even relative coordinates, you can put it in a relative drawing and then bring it in to a drawing that's in state plane. But it's quite simple. You can put a couple points in a drawing and then scale your image to it, and then use things like our Raster Design, if you like, for auto vectorization. Or you can leave it in its native state, use it as a backdrop, and where you see a visual issue with a, with a raster versus vector, then you could vectorize. So you wouldn't have to vectorize everything. So there's multiple techniques, but the key is to take that relative coordinate system drawing, drop it in a true system, and rectify it. And one thing, if you're a city or whatever, if you could, like on city blocks, get at least the intersections or some key points that would let you piece it together like a puzzle. So if you didn't have state plane or any control, get some in the field, tie it to your maps, and then connect it. I'll say this, things like subdivisions and that, and I've done subdivisions around the country. In the late 80s, they started getting us where we had to put on state plane coordinates on our subdivisions so the map cadastrals could drop it in the right coordinate system. So if a governmental agency, I highly recommend you have folks at least put 2 monuments on your drawing and give the datum so you can drop them in. So hope that answers that one.
Okay, great. I have another question here. It's a little long-winded, and it's kind of a 2 questions. How do you add a header to a point data file so it will transform the coordinate system automatically when it is imported? And secondly, where can I find specifics on what format the header needs to be in?
Okay, that's a very good question. Basically, in Civil 3D, if you go to Settings and then right-click on the top on General, and it's got Define Settings, I believe it is, you'll come in there and you have Units and Zones. And when you specify, for example, USA, California, NAT 83, Zone 5, US foot, it's going to come in with a thing that'll say CA 83 US 5. And it's a little thing on that dialog. It's the name of that projection. And in our help, you can look at it for like importing points. Look at help. And it will say, I can't remember the exact syntax, but I believe in the very header of the text file, you put in that CN, I'm sorry, CA for California, NAT 83, Zone 5. Whatever it says on that dialog, and the help clarifies it. It's extremely easy to do this. So you could be in a UTM, and say, what you do is, so you want to say I'm in UTM Zone 15 in the header. So when you bring the data into the active DWG, it interprets it, knows it's that. It's just like the survey database. It will convert it to the active DWG unit settings. Okay? I know that's a complicated thing I just said, but it's actually very simple. And it's in the online help in there how to do that. I hope that answers that.
Hopefully. Moving on to the next one, I think we have time for a few more. What does Civil 3D have built in for handling LiDAR data? And also, can you drape imagery over surfaces, whether it be survey data or LiDAR data?
Yeah, yes. We've been doing a series of webcasts. In fact, I'm doing another one Thursday on LiDAR classification and usage within Civil 3D and map. Thursday at, I believe it's 12 o'clock. And Noel, we could get the data out to everybody on that. But we've got several videos that have run through different techniques. But Civil 3D has the ability to load LAS, PTS, all types of LiDAR data, recognizes all the LAS data, such as information, the intensity, the RGB, if it has it, classification, all the different things like that. It recognizes it, so it can take it in, view it based, for example, bare earth. If it's already classified, you can toggle on bare earth. You'll see bare earth. You can say build a surface in Civil 3D from bare earth. So based on what's turned on from a point cloud, in point clouds you can have many millions of points in Civil 3D that you access, and we could say turn on bare earth, build a surface, and in 2011 it'll automatically build the surface from bare earth. Or if you want to look at high vegetation, you got classification of high vegetation, you turn it on, and you can build a high vegetation surface. So you could do clash detection for airports, things like that. So we have a lot of LiDAR capability in there. And then on the image draping, we have the ability. There's 2 ways to go. One is you can take an image and drape it on a triangulated surface, which is Delaunay criteria triangulation. So the Civil 3D surface, you can drape on it. And then it converts to a material and you can see it as you'd expect. Or the other option, and this is with our third-party kind of applications, you can take imagery, drape it on a point cloud, and change the RGB status of the point cloud. So then the LAS has the RGB, which lets you do all kinds of additional classification. And again, we're doing some of that stuff here in a couple days. So I hope that answers it. But we're very, very deep in LiDAR. We've got many techniques we can use. And we're doing a separate series just on LiDAR of webcasts.
Okay, great.
Anything else, Noel?
I just got one coming in, whether or not they can obtain a copy of this presentation. Yes, we will have, we are archiving this presentation, and information will be emailed to everyone in the webcast right now on how they can access it. One more question. Are you able to combine your mapping queries and solutions with your civil design?
Actually, that's what I've been doing. I mean, that's the biggest, one of the biggest things in Civil 3D is that we can sit here. Everything I showed can be done totally and only in Civil 3D. So I can do all these queries, find this area. For example, that problem area where I had the buffer zone overlap, I could have then touched that data, did what's called checkout feature, uploaded it through Civil 3D to a data collector, went out and staked it, found any issue with it, come back and updated the GIS from Civil 3D edits. So it's totally integrated. It's not one or the other. It's one and the same. I hope that makes sense.
Okay, perfect. I think we're just about out of time here. So David, I'd like to thank you. Those demonstrations were fantastic.
Thank you.
Everyone, at this time, this concludes our webcast.